Hello, 8th graders. We are doing problem set. We're actually module 4, lesson 2 problem set. We have to take the written expression and turn it into an algebraic expression and then determine if it's linear or nonlinear. So let's start with number 1. A number decreased. Decrease means to subtract. So to decrease a number, do we know that number? No. So we're going to call that number x, right? We're going to decrease it by 3 squared. Remember what 3 squared means? 3 to the second power, right? So we're going to go x, a number, decreased by 3 squared. Can 3 squared be simplified? What is 3 to the second power? Remember, the 3 to the second power means 3 times 3. And 3 times 3 is 9. So this would be the same as x minus 9. Then we have to decide, is this linear or nonlinear? And this is linear. It does not have a variable raised to a power, and it does not have a variable in a denominator. Therefore, it's linear. Number 2, the quotient. Remember, quotient is division of 2. So we're going to have 2 and a number. Do we know that number? So we're going to call it x. 2 divided by x. And we're going to take this whole quotient and subtract it from 17. So we're going to have 17 and take this away from it. So this is going to be 17 minus the quotient of 2 and a number. Is this going to be linear or nonlinear? This is linear. Let's go on to number 3. We have the sum. Sum means to add. So we have the sum of 13 and twice a number. We don't know the number, we're going to call it x. And how do we get twice x? We multiply it by 2. So 13 plus 2x, and that is going to be linear. Number 4. 5.2 more than. Remember, more than is a turnaround phrase. So 5.2 is going to be at the end, and more than means to add. So we're going to add 5.2. And we're going to add that to the product of 7 and a number. Product means to multiply. So we're going to multiply 7 and a number, and we're going to call that number x. So we're going to multiply 7 times x. So it's going to be 7x plus 5.2. And this is linear. Number 5. Once again, we have sum, which means to add. So we're going to have the sum that represents the number of tickets sold. If 35 were sold on Monday, so we have 35 on Monday, half of the remaining tickets on Tuesday. Do we know the remaining tickets? No, so we're going to call that x, and we want half of x. So to get half of x, we multiply it by half, so it's plus 1/2 x, and 14 on Wednesday. 35 plus 1/2 x plus 14, and this would be linear. Number 6, product means to multiply. So we have product of 19 and a number. We don't know the number. We're going to call it x. So multiply 19 times x. That would be 19x, right? And we're going to subtract it from. So it's what we're taking away from the reciprocal of a number cubed. Remember, reciprocal is when we take a fraction and we flip it, right? We take a fraction and we flip it. So if we have a number cubed, that's the number to the third power. The reciprocal would be it flipped, so it would be 1 over x to the third. We got to remember, we got to take the product of 19 and a number. We got to take 19x away from this reciprocal. So it would be 1 over x to the third minus 19x. Is this going to be linear or nonlinear? This is nonlinear. 2 reasons why. First, we have a variable on the bottom, plus our variable is raised to a power bigger than 1. Right? So because of that, it's nonlinear. Our next problem, we have the product. Product means to multiply 15 and a number. So we'll call that 15x. And then the product multiplied by itself 4 times. So we're going to take this product, multiply it by itself 4 times. Remember, when we're multiplying by itself, we're actually raising it to a power. So this would be to the power of 4. So this product, 15x, raised to the power of 4. Hold on. Okay. Hold on. Make this darker. There you go. So this is going to be nonlinear. Nonlinear because we have a variable raised to a power of 4. Okay. Next one, a number increased by 5. Do we know that number? We're going to call it x. We're going to increase it by 5. So increase means to add 5. And then we're going to take this, we're going to divide this whole thing by 2. A number increased by 5 and then divided by 2. And this is going to be linear. That's going to be linear. Okay. Number 9, 8 times the results of subtracting 3 from a number. 8 times the results. 8 times the results. So we need the results of subtracting 3 from a number. We're going to call that number x. We got to subtract 3 from x. So that'd be x minus 3, right? Subtracting 3 from a number. We're subtracting 3 from a number here. We want 8 times the result, so we want to take this whole thing and multiply it by 8. And this would be linear. Linear. Number 10. The sum, so we're going to be adding, right? We're going to be adding twice a number. So that if our number is x, it'd be 2x. And 4 times a number, so that would be 4x. So we're going to take this sum and we're going to subtract it from a number squared. Do we know the number? No, so it's going to be x squared. Take away this. And this is going to be, because we have our variable raised to a power greater than 1, then it is going to be non-linear. because of this. Okay. Let's go to number 11. 1/3 of the results. So a third of the results. We're going to have some kind of results in parentheses. We're going to take a third of that. 1/3 times the results. The results of 3 times a number. That is increased by 12. 3 times a number increased by 12. So 3 times a number increased by 12, and we're taking a third of that. And this is linear. Okay. Let's do the last 4 problems here. Number 12. 5 times the sum of 1/2 a number. 5 times the sum of 1/2 and a number. So the sum of 1/2 and a number, so we don't know the number, right? So 1/2 plus a number, and we want 5 times that. This is linear. Three-fourths of a number multiplied by 7. How do we get 3/4 of a number? We take the number, which we don't know, so it's going to be x, multiplied by 3/4. Then we want to multiply this by 7. And this is going to be linear. Here we have the sum, so we're adding, of a number and -3. So we're going to take a number x, we're going to add a -3, right? And that whole sum is going to be multiplied by a number. Now this gets tricky when we're deciding if this is linear or nonlinear, because we need to simplify this. Because if we were to use our distributive property, we would have x times x, which is x squared, then x times a -3, which would be a -3x. And because we have this is going to be nonlinear. Okay. Our last one, the square of the difference. So we're going to have a difference. We're going to square it. And it's the difference between a number and 10. A number, we're going to call x and 10. Find the difference, we subtract. So the square of the difference between a number and 10. And this, once again, we have a variable raised to the second power. This is nonlinear. But you can always call me or put questions on the question channel in Teams.